Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Software Architecture versus Software Design, Definition and Differentiation. Our guest speaker today is Mr. Suren Pururi, Assistant Vice President at Polaris Financial Technologies. Suren is a business-savvy, process-oriented, positive-minded, and a go-getter with a strategic approach to problem-solving and highest appreciation for values and dedication. He has a distinguished techno-management career qualified by over 20 years of measurable achievements in software delivery, pre-sales, architecture and design, product engineering, project engineering head role, solution engineering, account management, program project management areas. Suren holds an M.Tech in Computer Science and Engineering from NIT Warangal and is a B.Tech in Computer Science and Engineering from AU College of Engineering, Visit. He has worked for and served Fortune 100 companies in banking and financial services and retail verticals. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Suren.
Okay, thank you. Thanks for a nice introduction. Good afternoon, everyone. So the topic that I chose, the software architecture versus software design, it's a debate, quite a debate that's been going on in the industry, and there's so many experts have been debating it for quite some time. I'm just trying to give my own perspective. It's not that it will be complete by its own. So let me just set the context to this presentation. Just for a moment, all of you to wear software architect or designer hat for a moment, and then think about the software architecture and design disciplines, right? And if I ask you, is there a standard architecture design definition that's understood or interpreted by all in the same way? Then the majority of the opinion most likely is no. Right? Now let's switch the hats and switch for a moment. Let's wear the civil architect hats, and let me ask you a question. Is there a standard civil architecture definition that's understood and interpreted by all in the same way? Right? So then the most likely the answer is yes. The reason for that is, again, so if you, for example, if we are building your own houses, and the first thing we do is basically get the building architecture done. Right? Without which basically the contractor, nobody will actually start the house. But that's not the case, and in real practice when we're building an applications. Right? So now, given this context, right, let's look at the problem statement. Right? So what is fundamentally the problem statement? It says the architecture and design are buzzwords without standard and consistent understanding in the industry. Right? So does this statement make sense? Right? So is this a problem, a major issue or not? We will probably be clear to you by end of this presentation. Right? When we say the buzzwords, so isn't it? Okay. Now, I'm going to move on to the next slide where I'm going to expand the problem statement where I define here, right? Okay. Let's see here in slide 2, what is here the problem statement is. Okay, so I'm talking about this, right? So what is the problem number 1? The multiple definitions, right? Is this an issue or not? Okay, let's look at it now. Let's say somebody has to ask, say, what is physics, what is chemistry, what is organic chemistry, etc. Does all of us understand the definition of it in a consistent way or not? Let's now think for a moment, right? For a given word, when there is a consistent understanding exists, then job becomes much easier, right? Whereas the software architecture, you have multiple definitions, right? That's a big issue. Okay, so the reason for that again is all this, did it happen overnight for this physics, chemistry, and organic chemistry to become a consistent? No, right? It took few decades or centuries before these fields in same way. That way, the communication is smooth, at least within your organization, isn't it? However, it's not possible for individual no individual or organization to achieve the same level of consistency at a global level. The global level consistency is a natural evolution, right? Anything that's a global level is something that is not driven by a particular individual or organization. Okay, that's fundamentally the solution for the problem number 1. Now let's discuss about the problem number 2, right? So what is the problem number 2 we're discussing about is the multiple architecture standards, right? Okay, the multiple architecture standards, so that is fundamentally the problem number 2. So what are the standards we're talking about? It's TOGAF is one of the standards, Jackman, right? There's so many standards fundamentally exist, right? So which one should you use at an organizational level or a project level or an individual level? Okay, the reason why so many standards exist because no standard is complete by itself, right? Some standards are good in some aspects and some are incomplete in some other aspects, right? Okay, so now given that, what is the solution to this problem? Ensure that your organization inherits and adopts some of these standards and all employees are aware of and applies them consistently. So that is fundamentally is the solution for this problem number 2, right? So now let's talk about the problem number 3. Okay, so if you have to ask within somebody, can you create a design, right? A developer or a tech lead, probably the response that you will get is design means, that is means should I do the class and object and sequence diagram, right? That fundamentally is the response, right? So is that really so? Think for a moment. So is the design means, is that what it is? No, right? It's not correct. Okay. Fundamentally, what does it actually design mean? Design means a solution to the problem, right? So all these so-called class, object, sequence diagrams, etc., are tools that one can use in solving the problem, right? So which tool one needs to use depends on what problem one is solving it. Okay. Now let's switch the tracks. Let's look at some of the real life scenarios in terms of the tools usage. For example, plumber has, right, multiple different tools at his disposal and he has the skill and knowledge of using them, isn't it? So, for example, he will use for pipe leakages, he will use a different kind of a tool set. For pipe joints, he will use a different one, and replacing a tap, he will use a different one, isn't it? So, in the same way, when we're solving a problem in the software world, we need to be aware of the tool sets that are at our disposal, right? So, what are some of the tools that are available at the disposal? IDEs, debuggers, right? A class, objects, sequence, a diagram of the diagram, some of the templates, right? So these are all some of the tools that you need to aware of it. And then you also need to know which tool, when I should use it for solving a problem, right? That is very, very important for to avoid this confusion. Okay. Now let's look at the what is the fourth issue, right? No continuation between architecture, design, and coding, right? So in your organization, is the continuation exist in your organization between all these three phases, right? So can you create end-to-end traceability across these three stages? Isn't it? It's $1,000,000 question, isn't it? Just think for a moment. So why is it's absolutely important to have such a kind of a traceability, right? If you're building a civil architecture or a building, your own building, you have a civil architecture blueprint, right? So you have a traceability. There is an architecture is available, and then as the construction is progressing, you try to match what is in the architecture is being given, is the building is coming up according to or not, isn't it? But in the software world, are we doing that? Are we consistently tracking, doing the traceability, right? That's probably to a certain extent for a fresh development that there is a traceability that exists. But if you're going for a phase 2 or phase 3 in case of a maintenance, right, it's a chaotic state. So you don't have a traceability of architecture, design, and coding, right? Okay, now let's look at the final problem description, what we are talking about, right? How many of your organization within that where architecture design is created for process compliance purpose rather than the solution purpose, right? So the organizations, in order to actually get a good branding, they say CMMI level 5, CMMI, ISO and all, as part of that, which says a lot of documentation is required, right? So saying, okay, now we're doing that, okay, create an architecture document, yes, checklist is done, design document is done. So from the process compliance purpose, when something is being done, which will not be really, cannot be used in solving a problem, right? So see in this slide, why I spent so much time is it's extremely important to understand the importance of architecture and design. So, and what is it actually, or what sort of issues going to come up, right? So now we will move on to the next slide, where we will look at some of the causes of the problem, right? So we have seen the problem statement, and we have tried to expand the problem in slide 2 and 3. Now this slide 4, okay, so you might ask me, okay, you are saying that there is a problem, but so what does it actually mean when you say it's a problem? Explain to me in terms of what is the impact of this problem. Okay, that's a good question, right? Okay, so what is the impact of having this problem? Okay, the first impact of this is, okay, this one, right? The project delays and cancellations, isn't it? Okay, you might say, how does it causes this particular confusion or architecture will result in a project delays and cancellation, right? Let me give you the scenario, right? Basically, right, you create an architecture document and submit it to your customer. Customer comes back, no, 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 this is not what I'm expecting. I want an architecture means so many things, other things there. So it will come back to you, try to make the changes, and then goes to the customer, says. So look at it. So the architecture phase that was originally probably was given for 2 weeks, it might extend to 4 weeks. Even though it might extend to 4 weeks, you might not be successfully completing the architecture. Again, the fundamental reason for that is because the people that are actually all the stakeholders doesn't agree upon having a consistent scope and consistent definition for the architecture, isn't it?
So
So you
Sureen,
agree with me now?
I
So
would
how
like to
the
interrupt you.
this
Hello,
particular could be one of
Mr. Sureen.
yes, tell me.
Your voice is breaking. Can you
Yeah.
please check that you have closed all the other applications in your network connections? Your
Okay,
voice is
1 second.
breaking
I think
continuously.
I have closed everything. Oh, really? 1 second. Hello.
Yes, Mr. Sureen.
Uh,
Your voice is breaking. Hello, Mr. Sureen. Your voice is breaking. Not able to hear you at all. Are your network connections fine? Can you please check?
yeah, I'm also noticing that audio connection is actually, I'm losing the audio connection and coming back again. So should I dial into the phone?
Can you please speak now?
Yeah. Is it okay now?
Yeah, it's okay now. You can continue.
I can continue, or I can actually dial into the phone if you want me to. I can do that.
No, no, it's fine now.
It's fine now. Okay.
Yeah.
All right. Okay. Sorry, guys. Sorry for the this thing. Um, okay. So the how the this particular problem that I described we will call this, right? Project delays and cancellation is one of the impact of this particular thing. That's one of the things that could be caused, right? The second particular problem is cost of the maintenance is high. Why will the cost of the maintenance is high? Because the moment your architecture and design is not proper, then basically is whenever you try to fix one place, you might break it in another place. So the turnaround of fixing the problems could be high, and then you probably end up breaking the architecture, and then finally the life of a particular application will be instead of 5 years, it could be in 2 years, right? Okay, the third is the communication overhead. This is very important. So why within your own team, let's say if it's a team of 20 people or 15 people, and if all of them don't understand, don't have a common understanding of the architecture and design, what it means, and then along with it, if you add the stakeholders of your customers or your vendors and partners, it will be a big overhead because you have to explain to them this is what my architecture is, they need to understand it, they will have a different kind of an expectations, right? So that means you will end up spending a lot of effort in making sure that everybody is on the same page. That's where the communication overhead is there. Okay? Mismatch in expectations. This is absolutely right. Basically, when you know, for example, the country like in US, you have customers in the US where the architecture means they have very high expectations. Where you might go to probably some of the Middle East countries where probably in terms of the expectations could be low. So this mismatch expectations is again going to be a killer in terms of your own internal stakeholder. Let's say if you have your own architecture, the chief technology officer who is responsible for overall architecture, again you need to RPM, right? What is the other problem that's going to be caused? No consistency in the artifact. So we move from one project to another project and another project. If you try to compare, is there a consistency in the artifacts, right? So then again, it leads to basically the project delays cause, right?
Mr. Suren,
The most important, the sixth.
Mr. Suren, the voice has started breaking again. You would need to dial in through the phone now.
Okay, yeah, give me the number. I'll dial it to the phone.
Just a second.
Yeah, I don't know. Yeah, I'm also noticing it is actually going down and coming back again. So. Hello?
Suren.
Yeah, hi. Can you hear me now?
Yeah, we can hear you now.
Okay, great. Okay, so should I continue?
You just need to be a bit loud. You can continue, but you need to be a bit loud.
Yeah, sure, definitely, definitely. Yeah, definitely, definitely. Yeah, hi guys. Sorry, sorry for the interruptions. Is that perfectly fine, or should I a little bit more louder is required?
You need to be a bit more loud.
Okay. What about this voice? Is it okay now?
Yeah, it's good now. It's fine.
Okay. All right. Yeah. Hi guys. So the one more thing. So I was looking at the most important one is the
the benefits of architecture not known to the business, right? So why is it such an important thing? To look at it, so let's say you're building your own house, and if you, who is going to pay for the money, right? You are the paying for the money, right? So that means you need to understand the architecture before you pay for the money, isn't it? The same way in the business world, so the whoever is the business, the sponsor for this particular project must know clearly the cost of project and what are the project architecture benefits. So that is the biggest problem in the industry. So the sponsors are not so clear in terms of the benefits they are getting out of the architecture, right? So this gap needs to be filled up, by the architects and by the people. Okay. So and then finally the consumption utilization, right? So when you're actually creating the architecture and the design documents, are these documents are being effectively consumed and utilized by the people or not? That's extremely important, right? If you don't utilize it, what's the point? Okay. So far, fundamentally, we looked at it, what is the problem statement, the architecture and design of buzzwords, and then looked at the, in slide 3, the details about the expanded the problem, and then the impact of this problem in terms of the cost or in terms of the project delays or cancellations, right? Now, we will move on to the next slide.
Please put it in the full screen mode, Mr. Suren. Okay.
Yeah. One second. Okay. All right. Now, let's look at this, guys. Look at it. This was fundamentally more than 150 years back, when the 150 or close to 200 years back, when the civil engineering field was not at a mature stage what it is right now, right? So the reason why I brought up this slide is the architecture of civil, that particular phase of the time, and this architecture of software at this, where we are right now, probably at the same maturity level, right? See what happened, this particular house took 38 years of construction, right? 147 builders, okay? And look at it, basically 160 rooms, and then it has 40 bedrooms. And look at it, some of the issues this particular thing, right? There are 65 doors to blank walls, right? There are 13 staircases abandoned, and then there are 24 skylights and floors. Okay. So now look at it and then try to compare this with where software architecture. Some of these issues are some of the issues basically where we have a lot of dead code in the applications. Is that not familiar to us? We have a lot of dead code, a lot of unused code. So the dead code is equivalent to your 65 doors to the blank walls, right? So the unused code is like having a skylight and floor, isn't it? So all these are probably what? It's all because of, again, is the maturity level of the software architecture and design. And finally, if we look at it, this particular one doesn't have any architecture blueprint exist that particular point of time when this house was constructed. Okay. Okay. Now let's look at it, another construction analogy. Okay. So I have given 3 different scales of houses that are fundamentally can be constructed, right? So the leftmost, the easy one, if you look at it here, okay. So this one, It's a dog house, right? So can we build by one person, and it may not require minimal and simple process and simple tools. Okay? So this is like equivalent to trying to build a simple application in this thing, isn't it? Okay? So now let's go to the next one, where, okay? So if you have to build a house, right? Build most efficiently, and it will need to be, has to have a team. It requires an architecture, and it needs to have a well-defined process and power tools, isn't it? Okay. Now finally the complex one. Let's say if you have to build an architecting a high-rise, what does it require? It requires by multiple teams and partners, right? And it needs to be a heavy-duty architecture and complex process and sophisticated costly tools like cranes, and all those things are required, isn't it? So why I brought this again is, if you are building a software, doing a software architecture, right? So it all depends on what kind of a complexity of the problem you're addressing, right? Let's look at some of these things. What are the differences here? The scale, right? The smallest, the medium to the largest, and most complex, isn't it? So this is in terms of the perspective of when you're building a civil architecture, right? The process. Is the process remain going to be the same? No. The cost, right? Another difference is cost, a schedule, right? So the schedule is going to be the same again. So these are all some of the, the differences basically of, right? So now, does this ring the bell on you, right? All these things are absolutely again same true with any kind of a software development project, right? So these parameters will again, applicable, equally applicable for a software development project, isn't it? Okay. Let's move on to the next slide. Okay. I'm sure, I think this is all of you must be eagerly looking for to this particular architecture definition and then the design definition, right? Okay. So let me try to give a very easy definition that can be remembered quite easily for all of you, right? There are many definitions available at CMU website, right? So there are many definitions available. Okay. So if you look at it, all these definitions, the essence is absolutely same, right? What does it actually mean? Architecture means structure and behavior of a system, right? If you take any definition, anything, and fundamentally try to interpret it, this is all fundamentally solved. So when somebody asks you next time, what is the definition of a software architecture, your going to be simple, easy answer is software architecture is nothing but structure and behavior of a system. And I'm doing that, then I think it's very easily understand by a business people or a technical people, right? In an easy way. Okay. Now let's try to expand this. What does it actually? It includes the horizontal ones, right? That's fundamentally your process structure. Vertical ones, like a presentation, right? Your logic structure, plus your data access structure, plus your data model and data structure. So this is what fundamentally is what is all about the architecture, isn't it? Okay. So if you have to do the analogy from the construction perspective, the pillars plus beams equal to the structure of the building, isn't it? When somebody says, so why it is a structure of building is because those pillars and beams are not something that can be changed easily, isn't it? Whereas the walls and all, you can actually remove a wall and put a wall, but can you do that with your pillars and beams? No. So So that's where this civil architecture also make sure that the right amount of pillars, right size of the pillars is where the civil architecture is addressed and all this, right? Okay. Now let me give you easy definition of a design. A design is nothing but a structure and behavior of a module, right? So the difference between architecture and design is fundamentally looking at a lower level granularity where it's talking about a particular module, what is the structure and behavior of a module. It's like a part, right? To make it easy, let me give you the next analogy in the next section, next slide, right? Let's look at it another car analogy, right? So in this car, what are some of the things? What is the equivalent of a software architecture here, right? So this whole thing is they were equivalent of a software architecture, right? And what is the some of these modules, right? For example, your engine is one of the modules, right? Your tires is the another, the modules, right? Isn't it? Okay. So when somebody has to build a car, so there is an equivalent of an architecture that needs to be done, right? And then the equivalent of a modules like your engines, your tires, right? So those are all need to be again done, and then both of them need to be plugged together to actually build a car, isn't it? Okay, in order to plug together, there is a standard interfaces fundamentally are defined. For example, the car has to be of this size, right? And then this has to be fixed in the whole engine has to be this dimensions, it has to be exactly fixed, isn't it? So these are all, that's the reason the car industry, you have different companies which manufacture the parts separately from nowhere related to the car manufacturer, and then they bring this part and then they join together and you have a car. Or are we there in the software, the software development field? Can you do that? Can you have a part manufactured somewhere by an unknown entity and bring it in and then join together and build a final product, right? We are not there yet, right? So even though the components market is growing, still not there, it's not yet mature to reach the stage of a manufacturing of a car, okay? All right, let's move on to the next slide. Okay, this is the most important one so we have seen the definition of an architecture. We have seen the definition of the design. Now we will see in this slide what is the scope of an architecture. Okay. Okay. All right. So when somebody has to ask you and give the software architecture, right? So what are all it contains? Navigation architecture, right? So in your application, what kind of a navigation are you going to put together, right? Don't you need to have a structure for that? Yes. So when at the time of software architecture, the first thing you need to have is your navigation structure, right? The second thing your architecture should contain is a page structure, right? So what are all the different types of pages you have? You have some maintenance pages, transactions pages, right? Report pages, right? So you need to have a template structure for each of these pages, right? That's where the page structure is absolutely important. Okay? This is about, again, part of your software architecture scope. The third thing is validations, right? So So when you say basically, what are all the kind of validations does your applications? You need to define a structure for it. What kind of a client-side validations that I am going to? So you need to have a provide a structure for that. That's the way the validation structure is again part of your architecture scope. The fourth one is logging structure, right? So when we say there's a logging structure, so the question is what information need to be logged at a process level, at a layer level, at a module level, or a lower granularity level. Again, you need to define, put it in the architecture. The fifth one, exception handling. What are all the exceptions? What is the structure of exceptions? And exceptions at a system level, process level, layer level. This is again need to be part of your software architecture. Okay. The sixth one is the most important one. How many unique use cases that I have, and what is the process flow for each of the use cases, right? The presentation to business logic to data access layer. Okay. So this is extremely important. So once you do that, then you will have your software architecture complete for those use cases. So then what are those design patterns, that architecture design patterns that you need to use, right? Then with deployment decisions, am I going to doing the the client deployment, the web kind of a deployment? Am I going to do the active, is it a cluster deployment, an active passive, or an active cluster? These are all again has to be part of your software architecture, right? What kind of an architectural style? Is it a client server or a web or SOA, or what kind of an architectural style? That decision you need to be making it. The most important again, layering decisions, right? How many layers? Whether there are 3 layers or 4 layers or n number of layers. So if you have defined the more number of layers, then what is the responsibility of each of layer? What are the layer interfaces, right? Then business objects representation. How are you going to define your business objects? Is it going to be? I'm just bringing an example of Java here. So in case of the technologies you can use there. So in case of Java, you're using EJBs or POJOs. So how are you representing your business objects? That again has to be part of the software architecture. With database usage, right? So are you planning to use data only as a data repository or data repository plus business logic, right? That again is a decision that has to be part of your software architecture decision, right? Again, database access layer structure. So are you going to use your RDBMS or DDBMS or ORM? How are you planning to access your database? Then the last, but not the least, the most important is security structure, right? What is your authentication layer? What is your authorizations layer? What is your audit? How are you going to do that? So these are all, if you look at it, the software architecture, when you say complete, just go through this, try to expand it, make sure that you have done everything, then only your software architecture is complete. Okay, so clear? Okay. All right. So what's the scope of a design? Right? The design scope fundamentally is the internal structure and behavior of each of the modules, right? So in terms of the module, for example, so to give you a quick this thing, let's say the car, tire, or engine could be a module. But what is the structure of an engine or car, tire, right? So and then so in the architecture phase, you don't define all the pages, right? You don't provide the concrete UI for all the the pages, right? So you do the concrete user interface pages design at your design scope level. So take a module and then so what are all each of the pages, and then you do the user interface design at the design level. and then your algorithms design, right? So for a particular module, so how am I going to process my data? What are the logic that I'm going to use? What are the algorithms that I'm going to use? Right? What are the stretch algorithms I'm going to use? Or sort algorithms I'm going to use? All that. So you're going to provide the flush out all the details at a design scope level, right? And then make sure that the classes that you define are based on SRP, single responsibility principle, right? This is extremely important. So one class need to have one responsibility. That is a fundamental rule. If you look at it, again, this is where a lot of organization, a lot of architectures fail, right? You take a single class and, similar to structured programming, and then, you put everything in a single class and then try to imitate your object programming, right? If you want the real object-oriented programming, the fundamental principle that any class must meet is every class should have a single responsibility principle, okay? Clear? All right. Okay. Now let's look at it: architecture versus the design. Right? What is the architecture? Right? The architecture is system decisions. Right? Architecture fundamentally, any decisions that you are making at an architecture level, the scope is the complete system. So keep that in mind, right? The scope of an architecture decision is entire system. Clear? Second fundamental principle, harder to change decision, right? So similar to your pillars and beams, right, which cannot be shifted easily once constructed. The similar way in the software architecture world, the architecture decisions that you make are very hard to change if you want to. So that's why it's extremely important, a lot of focus on the architecture. So the scope again is system. Clear? Alright. So what is the design level we're talking about? The decisions are the scope of related to a particular module only. Okay? Second, easy to change. The decisions, let's say you made a wrong decision, it's possible to go back and make the change during the construction phase also without not having a major impact. Whereas here, let's say if you realize that during the coding some architecture is wrong, that has a huge impact on your cost, your deliverables, the quality, entire thing will go for a toss, right? So what are all the decisions in terms of the architecture? Look at the slide that I've given, right? Those are all fundamentally your architecture decisions, right? The scope is module. Okay? Clear? Okay. All right. Before I, talk about this, I just want to know, I have not created any slide for this. Just want to highlight some of the cultural aspects that has a huge impact on this, the Indian software industry especially, right? Why am I talking about it culturally here? So if you look at it, any of the Indian IT organizations, so look at the structures, right? You have project leads, project managers, and then project directors, and basically the business units. These are all fundamentally based on the delivery focus, right? How many IT organizations have fundamentally a structure of, in terms of the technical in nature, where it is being encouraged? Okay. See, in our Indian culture, right, we feel proud to say that I have 50 people working for me, 20 people working for me, right? 100 people, I have a $5 million, right? How many of us feel better I'm a great architect, I'm building this solution? So we might, but those are social pressures. When you go home and basically talk to your friends and peers, saying I'm just doing software, you say, what? You're doing alone, you don't have any people, so you have 20 years experience, don't have any people reporting to you, right? It's a fundamental in the culture, right? Whereas in US and other countries, if you go there the people, even with the age of 50 or 55, they're very proud to say that, I'm an architect and I do take care of complex solutions, right? This is again where the industry is fundamentally suffering because there is not much. I think slowly people are realizing it and then trying to build the career options in the architecture field, but it's still there, but still a long way to go. But that is extremely important. If one has to succeed and really become a leader, a strong project management is important, strong architects are important, strong delivery is important, strong quality is important. When all these 4 dimensions are taken care, then basically we can proud to say that right. So we are leaders in the software industry. So that's why I just wanted to highlight that cultural aspect. So which is actually preventing a lot of people from taking up the the career, right? So when after becomes a 3 years or 4 year experience, then he will be put in a project lead. Then he will lose touch with so he will not be able to acquire the depth, the technical depth that is required fundamentally in going into the project architecture. So unless and until you keep solving the software architecture, becoming and acquiring the knowledge continuous basis, you will not acquire the depth that is required for the software architecture and design, right? Okay. Let's look at this slide. So let's look at it, right? What's wrong with designing a system that has one big source module, one big object module, and one big executable as long as it functions properly? So how many of you agree with this statement? See, there are a list of functional statements are given, and then built this a huge, this thing which functions very well. It takes care of all the functional requirements. So is this correct? So then can we go and deliver this to the customer, right? Okay. This is where the non-functional aspect, right? Modifiability, right? It's not that you deliver it and go. So it needs to be changed on a continuous basis. So if it's a huge thing, will you be able to change it? Right? It's a big question, isn't it? So will you be able to modify it? No, right? How can you test it? Is it easy to test? Complexity, right? Understanding it is extremely complex. When if you have, let's say, 1 lakh lines of code, right? So it's extremely complex. You can't maintain it, right? What are all these aspects? These are all non-functional, maintainability, right? If you can't maintain it, so if you look at any application, the application will evolve over a period of time, and right. So it's period 3 years or 5 years or 7 years, depends on the complexity of the application before any application matures. That means it will go through n number of release cycles, right? So this is maintainability. Portability, right? So you want to deploy it across multiple systems, Unix systems, Windows systems, or Mac. Reliability, right? So distribute, are you able to distribute it easily, right? The most important again, availability, right? Is this system is available, right? It could be functionally, thing, but is available. Is it available 99.99%, right? Is it reliable? Is it producing the result consistently, right? So if somebody has to build this huge thing, so all these non-functional requirements will get failed, isn't it? Okay? So the reusability, right? So again, the reusability is extremely important, right? So unless and until you are able to reuse some of the things that you build in one project for other projects, then the organization that developing it is not evolving, right? Okay, the final point. If the functionality is the only thing that matters, any software architecture will do. Again, remember this statement. If functionality is the only thing that matters, any software architecture will do. Other things, non-functional aspects are the one that actually makes all the design constraints and quality attributes. Okay. All right. Thank you, guys. I think that's all. Is my presentation. I hope I covered all the expectations. Okay. Yeah, I'm done. I think I can take the questions. Okay. I think I have received a question. Can you elaborate more on the SRP at the end? Right. That's the question. So the single responsibility principle, right? Let's say you created a class. Let's say the class is supposed to create only entities. Okay. Let's take an employee class where its responsibility is only to create employees. Okay. Now, in the same class, let's say if you add searching of an employees also, that means you're fundamentally violating it. Right? So that is what it means by the single responsibility principle. Right? A single class should do a single responsibility effectively and efficiently. That's what it is. Okay? Right? Okay. The next question is how to tackle reliability. Okay? Right? So when somebody says, do we know what is reliability means? The reliability is nothing but the application has to produce the result consistently, right? I should be able to reliable. Let me just give you an example, right? Why do you go to Amazon.com or eBay.com and order the products, right? Because you are trusting them that when you put an order, basically the order will go through, right? In case of an error, you will not be charged, right? You are assured of getting your product. That's what fundamentally is the reliability, right? So the system has to reliable, it has to function relating. How do you tackle reliability? Reliability is nothing but your software architecture concerns. So if you take care of your architecture effectively, then automatically your reliability will be handled. Okay? Okay, the next question that I have is from slide 5. I have a question. When they start to build this Winchester mystery house from the planning, okay, yeah, what is the question? I'm not seeing any question here. So where I don't see any question here. All right, I'm just moving on to the next one. Okay. What are the steps we need to keep in this basically from Amrit Mishra? What are the steps we need to keep in mind while designing the architecture and while creating the design for an application? Right? What are the steps fundamentally? If you look at, I think the steps I've shown it in my slide there. What is architecture scope? So, so those are all fundamentally are the steps that you need to take care of it. Fundamentally, your navigation structure, basically your user interface structure, your business object, right? Those are all fundamentally are the steps you need to take care of. Okay. Okay. The next question is, could you please clarify how portability matters here? Okay. So the portability matters a lot, right? Let's say you want to build a system that's not portable, right? As an organization, now the decision was to go with the Sun Solaris system servers, right? Now let's say if organization make a decision that now we don't no longer want the Sun Solaris, we want to move, everybody wants to move to Linux. If your system is not portable from Sun Solaris to Linux, look at it basically. Do you think that the decision can be enforced? No, right? So the portability matters a lot for an enterprise level, isn't it? Okay. Next question. You simply, in success in IT, you need to have in-depth technical and architectural knowledge. So what steps need to be taken while working? That's already. Okay, very good question. That's already. So the way to do this is, the first thing, let's say we are a developer working in an application, don't, restrict yourself to a particular, use case that has been asked to work for it. Make sure that you understand the entire application, make sure to understand the architecture, make sure to understand the design, right? So even though you may not be doing the design, even though you are a developer, so let's say you completed 6 months in the project, you should be able to explain the architecture of the system, design of the system, data model of the system, right? That's how you can actually evolve yourself from a developer to tech lead to designer to an architect, right? But not many people are doing it. So what they do is they do the coding and saying this is what I did. If somebody asks you to explain the application, whole application, they will not be able to explain it. Okay. The next question, MVC is design or architecture. Saurabh Jagati, sorry, actually the nature design or architecture, it's fundamentally a pattern, right? It's a pattern of solving software problems. Okay. Okay, next question is, don't the hardware available and the OS used also come under architecture work? Fina, Lana. Okay, no, fundamentally we're talking about the software architecture here, right? See, the hardware available in OS use, these are all fundamentally your deployment decisions. Again, yes, if you look at it, this architecture scope that I given, the deployment decisions are also part of the scope. So from that perspective, yes, which servers you're going to use, which firewalls you're going to use, which OS you're going to use, those are all also your part of your decisions. Okay? Okay, the next question is, can you please explain the different types of architecture along over the nation? All right. Okay, the different types of application architectures are like, one is the software architecture, you are aware of it. The second level is enterprise architecture, right? So the enterprise architecture is, so you don't focus on a single application. At an enterprise level, what should be the structure of my IT system, right? What should be structure of my, the server? Those are, you are fundamentally defining the, at an enterprise level, what are my business processes? How are the, business is going to run? How does the HR connect to the sales, to the marketing? How am I going to do the delivery, right? Those are all fundamentally is at an enterprise architecture, right? Another architecture is your information architecture, right? And then your data architecture. Those are the various types of architecture. I can quickly tell you about like the nation. Okay. Okay. Could you tell me how the distributability matters? All right. It's a very good question, right, guys? So if you look at it, the client-server applications, why the client-server architecture failed, and then basically people are moving into the web architecture. The actual reason for distributability. In the client-server architecture, what happened was the thick clients need to be distributed to each PC and client, right? They need to be, fundamentally, distributed, deployed, a lot of, installation issues and all. So why web is popular is you don't have to deploy anything at all in individual PCs. That's where the distributability matters. Unless, if you look at it, in organizations like, that has 1 lakh employees, right? If you want to distribute an application to the 1 lakh employees, it's extremely important, right? That's where they know. Okay. Okay, all right. In your knowledge, experience, what's best architecture approach, Prabhat or Chapman or anything else? Karikalam Thiru. Okay. So again, if you look at my presentation, I've said it clearly, right? It's not that you can't compare, one architecture with another architecture, right? And so this is the best. I said, these architectures are, not good in certain aspects. They're probably, not okay in other aspects. So the way you should look at it is, you should understand what is TOGAF, where is it actually good at, right? For example, the TOGAF and Chapman both are enterprise level architectures, right? And then in what context, it's like these are like tools, right? You need to understand what they're good at and then see, look at the problem. If there is suitable problem for using these tools, use them appropriately. That's how you should look at it. It's not that, you cannot generalize it, say this is good, this is bad. That's not the way one should look at these architectures. Okay, all right. The next question is, I mean, when they started to build the mystery house from initiation to closing phase. Okay. So sorry, I think you have started your question somewhere. Okay, then they start to build this. Yeah, it is fundamentally, again, Shalupati, yes, it is from the initiation to the close is what is fundamentally is that 38 years I was talking about. Okay? Shalu Prashant, all right. What is multi-tenant architecture? All right? Okay, this is Nitendra Godare. The multi-tenant architecture is the one, so where this is the one in the cloud-based deployments, right? For example, so you can have the multiple organizations that are sharing the same application. The best example is Salesforce.com, right? Where Salesforce.com application is being used by hundreds of small and medium customers, right? So where they're probably deployed on the same set of servers. So that means the server has multiple tenants. Why it is called tenant? It's like an apartment where you have 20 apartments. Those apartments are being shared by the 20 tenants. That's why it's called multi-tenant architecture, which is the word that's used in the cloud-based deployments. Okay. All right. The next question is, can you please explain how to transform from senior developer to architect? What are the different things I need to learn? Okay. Good question. The first, again, I was explained to you earlier at all. See, let's say if you are a developer worked on for last 3 years and 4 years, the first question you should ask is, am I able to explain the architecture and design of these 3 or 4 systems that I worked as a developer? Right? That's a thumb rule. The moment you do that, you're making a progress. So don't stick to your role of just doing the coding of this particular use case or this particular module, and then when you go into saying, I know about this. So as a developer, you need to understand the entire system, understand the architecture, understand the data model, right? It should be explained to your architecture. The moment if you can do that for first 3 or 4 projects as a developer, then you're slowly making a progression towards architect. Okay? Right? Change at architecture level is hard, whereas design level is somewhat easy. Can you please explain with an example? Okay. Alright, this is Satyanarayana Raju Vanga. Okay, yes, so I will give you an example, right? Software architecture, let's say your process flow, right, that you have defined in an architecture level. Okay, now that flow, let's say you have defined an architecture which is very hard to change, isn't it? So you have defined the process flow, and which will be used by all your use cases, right? If you change your process flow, that means all the 20 or 30 use cases that you have will get impacted, right? So isn't that hard to change? Yes, right? That's where I'm saying is basically the hard to change, right? Okay. see the design level changes, for example, okay, so let's say, your employee search, right? So you want to change your employee search algorithm, right? So which you find it in a better way of searching it. That's an easy change, right? All you have to do is replace this particular search algorithm with another algorithm, which you can do at any point of time. It doesn't have any impact. Whereas in earlier case, so when you make the process flow architecture change, you are fundamentally impact the entire application scope, isn't it? Okay. All right. What's the benefit of TOGAF certifications? That's already, right? Okay. So the benefit of TOGAF certifications fundamentally is it will give you the, first of all, credibility in the market. The saying is, yes, you are enterprise, the enterprise architect certified, right? And so you can, tell, your customers are saying, I'm TOGAF certified, I'm enterprise architect certified. That's one of the benefits of the TOGAF certification. Just not the certification is not good enough unless and until you put the actual, TOGAF in benefit and use. You will not be really claiming any credit out of it. Okay. All right. The next question: will not many design changes in the software development affect its architecture? Because changes made at the modular level will affect system as a whole. With all the sure, right? Okay. Okay. But, that's not really. I think you're contradicting your statement. I said the design changes at the scope of a design changes at a module level, right? So if a particular change is impacting at a system level, then that's an architecture change, right? You need to clearly understand it. The question that you are asking is, a module level changes having an impact on a system level, that's not true. Okay? The next question is, when we are maintaining the existing software, what can be the possibilities to follow software architecture where I can maintain it? Gopal Omar. When we are maintaining the existing software, what can be the possibilities to follow software architecture where I can maintain it? Okay, so when you're maintaining the existing software, make sure that you take the existing software architecture document, right? Whenever you're making changes, make sure that the architecture is updated, design is updated, then before doing the coding. That's how you maintain your software architecture, design and coding in it, so you can trace it. Okay. Okay. I mean, what kind of tools we need to use for designing the better application architecture? Krishna Kumar Brahmarautu. Okay. See, the application architecture, there are tools, a lot of tools are available. Rational software architect is fundamentally, one of the good tools that's available. It's more than a tool, is your approach for solving the problem is extremely important, right? So like I was telling it, so the plumber will have a lot of tools at his disposal. So if the plumber doesn't know which tool to use, what to use. Similarly, if you know the rational software architect, but doesn't know how to solve the problem effectively, then absolutely the tool is useless. So first of all, tool is required. You need to have the knowledge of the tool. The most important thing is your approach for solving the problem using the software. That's the most important. Okay. So any more questions?
Well, and that is all we have, Mr. Sureen. Thanks for your session on software architecture versus software design, definition and differentiation. It was indeed a great session.
Yeah.
I would also like to thank
Thank you.
all our participants for the support in making this webinar a success. The recording of this webinar will be available on techgeek.com by tomorrow. Thank you all. Have a great evening.
All right. Thank you. Thanks a lot. Bye.